Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at a few trends, focusing around kind of the area of artificial intelligence for a while, but I'm not going to be talking about trends about AI for the whole topic. I am going to focus on Linux.org for a little bit, and then a little bit on ARM, and then a little bit more on RISC-V. So let's get started right after this. So I thought maybe what I would do this time around is that in the past I've always done this kind of as I'd taken each one of these subject areas separately, and I thought I'm going to update a video that I did on RISC-V last year. At the end of last year, I think I did an update, and so I owe you one again to tell you what's going on right now. And then ARM, I want to talk a little bit about what's going on with them beyond what I'm doing with it, but and then a little bit about just correcting some things that people are saying about Linux and its market share. Yeah, myself included, I've been guilty of this as well. So recently came across some more data and been looking at it a little bit more, and I'll talk more about that as we get going. So artificial intelligence trends. So the market is growing at leaps and bounds, as you can imagine. Right now, they're expecting it to go to $700 billion by 2027. And the growth rate, the current compound annual growth rate is around 42% each year. So yeah, it's pretty fast. It was at about a 2x growth rate, and now it's starting to pick up again. There's signs that and some predictions by some of the marketing people that they think it might hit 10x growth rate sometime, maybe next year, maybe the year after. Don't quite know if that will hold true or not. But we'll find out. But the Moore's law, of course, the ability to increase processing power by 2 times every 18 months, that's been falling behind, and we all have seen that. So the GPUs are picking up the vacuum that the CPUs are leaving in order to be able to provide the amount of processing power that AI needs in order to continue its growth. But there's some other things that's happening in the GPU field as well. There are GPUs that are now being differentiated between their tasks. There are some that are dedicated for training. There are some that are dedicated for inference, which is the actual running of the model. And then there are some that's dedicated to the edge and IoT, like the ones I showed you here the last time I did a video yesterday. Or Monday, actually. No, Wednesday, right. So artificial intelligence trends, a couple of things that have happened. China's Cambricon IPO'd for $3.1 billion recently. Intel has acquired Habana for about $2 billion. There's more startups in 2019 than there were in 2020, and I think that's because of the current health situation that we're running into, and that is definitely slowing things down in the industry. CBI Insights reported that Apple has acquired 20 AI companies, Google 14, Microsoft 10. There's a longer list. There's Facebook and Intel. They've all been acquiring AI companies. So, yeah, this is a pretty heavy field, and a lot of people are moving quick to capitalize on it. A few have folded, and of course that's to be expected. Well, we haven't yet reached. See, there's always this trend where new technologies kind of sit for a while. They kind of grow at a little rate, and then they spike. They hit at some kind of a peak at some point, and at that point is where you usually see consolidation just after the peak as it starts to fall. You'll start seeing a shakeout in the industry, and things are starting to there's a lot of people that get left behind, a lot of companies that fail. I don't think we're there yet. I think these are just companies that can't get their first round of funding because they just weren't able to meet their requirements to get that second round. Cerebas, AI company, they announced the largest chip ever built. It basically is the entire die to fabricate this chip. They solved a 70-year-old problem in chip design and fabrication, and the smaller chip in the right-hand corner is a traditional GPU. So it's quite large, quite large. It is being used in the largest AI supercomputers, and it provides, they're currently building an 800,000 core AI supercomputer with HP for the Pittsburgh Supercomputing Center. And of course, they won a contract with the Department of Energy last year to construct one of the largest AI supercomputers in the world. This image that's up in the right-hand corner is their CS1 wafer scale engine, and it has 1.2 trillion transistors. And just to give you some comparison, the graphics processor next to it is about 2.1 billion transistors. So yeah, it's pretty significant. 400,000 AI cores, as opposed to a few hundred on the other one. 18 gigabytes of memory on chip. Now that's not memory and RAM, that's memory on chip. And 10 petabytes per second interconnect performance. So very fast, very big, very impressive, and uses a lot of power. So I hope you have a power station handy to use this one, because it's going to take a lot of energy to run it. But it is definitely an accomplishment, and it's pretty amazing as to its capabilities. So, just briefly on Linux.org. So the one we always talk about is the chart on the left, which is showing Microsoft at about 77%, 78% market share, followed by the Mac OS, then Chromebook, and then Linux is down in the weeds down on the right-hand side of about, floats around 2%. But there was one thing I remember back in my past when the mainframes were they didn't know they were being threatened by the PC, but they were, and by the PC-based servers. And who was the first ones to adopt? It was the developers. And no one looked at those signs as to what the developers were doing. Well, here's the thing. If developers are using a particular platform and they're developing software, the businesses that want that software will have to adopt the operating system that it runs on. And so I went back to one of the questionnaires that was done last year by Stack Overflow, their 2019 survey, and found some data as to which servers the developers were using, and I was surprised to see this one. So currently the Windows platform is about 46%. And that's followed by Mac OS. Now, I have used Mac OS for development in the past. It's a very good platform for that, but it doesn't really suit my needs much anymore. And then Linux is about 1% less than the Mac OS, at about 26%, something like that. So you have about 46% Microsoft, about 27% Mac, and then about 26% Linux. And BSD is used still, and it's kind of down in there somewhere about 1% or a little less. So the thing you want to watch out for is, in trends, is, watch this one. Because in the past, where developers are sitting and where they're working, they aren't just working, those developers are not just working on servers. It's pretty easy to say that, but developers write software for applications, and they don't care where it runs. So if there's something that is useful for the desktop, it'll show up, and that will change that graph on the left in a big hurry. The transition from mainframes to PCs was less than a year. It went that fast, and no one saw it coming except for a few of us. And we were laughed at. People thought we were crazy. Oh, no, those PCs will never take over the more powerful mainframes. And they have, and they are still to have the bulk of the data center today. So anyway, ARM. Let's talk about ARM for a minute. So the self-hosted servers, that is the traditional in-house servers that your company maintains, that is a declining market, unfortunately, and that has been steadily declining over time since about 2005, 2007. It's been slowly declining. And market data released by Statistica and others show that the decline in sales is approximately 4% a year for the servers. It's about 9% overall for all x86 platforms, and that includes laptops and desktops. So yeah, in 2020, because of the current conditions in the market, they're expecting about a 5.5% decline in the server market. x86 revenues in PCs were $180 billion in 2019. Servers around $90 billion. On the other hand, same year, ARM has gotten about $800 billion in revenue. Now, that's not ARM, the company, but companies that sell ARM-based systems, and that includes the phones. In fact, that is the phones. So where do you think, if you were a company investing in technology and you wanted to make the most on your return, where would you go? That's the question you have to answer. Gartner predicted in 2018 that by 2025, 80% of the enterprises will shut down their traditional data centers in favor of the cloud. You know, I don't know if I necessarily agree with that, but it is certainly happening. There's no question about it that there is a huge transition underway to move from the data center to the cloud. Apple, of course, and we know that they're moving to. I know one of the guys that is a developer for Apple that has a channel here on YouTube said that no, it's not ARM, it's Apple Silicon. Well, here's the thing: if it quacks like a duck and it looks like a duck, it's probably a duck. If it runs ARM code and it uses the ARM instruction set, it's probably an ARM-based product, even though it's heavily modified by Apple. So that's my take. So unless it's running some other instruction set, it's ARM. So anyway, that's my take. Amazon launches the ARM Graviton 2, which is faster than the currently deployed Intel Xeon and AMD EPYC first gen. That's the Naples, not the current one, not the second generation one. So I don't have any data that compares the Graviton 2 to the second generation EPYC. But I do know that Amazon is definitely moving in the direction of deploying more and more of the Graviton. But the last I saw on AWS is they were giving people the choice, and it was costing less to go with ARM. So again, that's kind of self-fulfilling prophecy there. I mean, if it's cheaper, I would imagine that they're probably going to have more demand for that chip. And of course, the Graviton is an Amazon designed ARM chip as well. Even though they designed it, it is still called an ARM. Apple. Anyway, predictions from industry. So in the year this was an old one. In the year 2000, 100% of the enterprise purchased servers from a traditional data center. So, I mean, as far back as 20 years ago, you were going to HP and at that time, IBM, and also Dell and probably Sun at that time, and purchasing your servers from them, Oracle later. But yeah, you were probably going there to purchase your enterprise servers for your data center. In 2020, there was a lot more money spent on the cloud. There wasn't any money spent on the cloud in 2020, but $100 billion was spent on cloud infrastructure. 2025 is predicted that will be $400 billion. So I don't know if that lines up. I don't know what the total number of servers, what the purchasing of the global markets are. Everybody wants you to pay for that data, and I'm sorry, I don't want to pay for it. ARM will begin, now this is another prediction, it's not mine. ARM will begin transplanting traditional x86-based servers beginning in 2020, and they expect that trend to continue until 2025. And then there's somebody else that's coming in that will provide a threat to ARM. And I don't think that AMD is out just yet. I mean, the EPYC processors in Generation 2 and the new ones, the Generation 3 that are coming, are pretty powerful, and they have a very good price performance. So, or price per watt, if you prefer to use that measurement, but that's what it's all about. It's all about price performance and price per watt. So I don't know how that prediction will stand. I'm sure AMD will have something to say about that, as will Intel. Ecosystem. So I saw this comparison and I thought it was really good. It's in the beginning, software, we had proprietary operating systems that were controlled by a few. Some of those operating systems are still around today, and I think you probably know one of them. But Unix was really the first to license their operating systems, and that generated quite a bit of excitement in the early 80s all the way until the 90s when it self-destructed. But Linux was the first one to open source their operating system with no cost and no licenses attached to it. We're seeing the same thing in hardware. In the beginning, we had proprietary hardware, CPU designs, like the ones from the current providers of CPUs today. ARM was the first to license their CPU designs, and now RISC-V is the first to use open source or to open source their CPU designs. So if open source is what we want, and I think we do. We've seen recently the issues that Intel has had with their security, and then just recently, yesterday, with a 17-year-old bug that's been in the Windows platform that's affecting everyone. By the way, that is on a CVE scale of a 10, it's a bad one. So anyway, patch your systems if you're on Windows. The Linux ecosystem has been working to provide additional support for RISC-V. So QEMU, as you know, is the emulator that sits between KVM and U. So it's the one that can provide emulation and the interface, the API, and allow you to start and bring down your virtualized systems. But they're now building support for RISC-V emulators, which is very good. But I'll explain why that's good. RISC-V boot flow using U-boot, similar to the way ARM does it. There's a super I don't know if you know much about how these technologies works, but the SBI is how you flip between the hardware and the kernel. It's how you pass messages or firmware onto the hardware and then have it run, and then flip back to the kernel to get things to execute. But that's now built into the Linux kernel. You have UEFI support for RISC-V. That's now in kernel 5.8. Release candidate 5, I believe, has it, which is the current release of. Well, it's not stable, but it is the current release of the kernel. Berkeley packet filters, or JIT, is now part of the kernel. KGDB, which is one of the debuggers. KExec, KDump, and build with Clang. So there's a lot of progress going on in the software front. It seems like there's really a rapid amount of progress on RISC-V. And I think this is, I don't know what their projections were, but this seems like it's really ahead of schedule to me. There's not a whole lot of hardware that's available yet. Sci-Fi released their Unleashed a few years ago, but they're not a SoC manufacturer, they're a chip manufacturer. So they kind of did that in a limited fashion as a proof of concept. But it is out there still, and you can probably find them if you look. There's also the Kendrite K210, I should say, which is it's like it would be similar to the Raspberry Pi, the really small form factor, like the Adafruit sized form factor SoCs. It doesn't have very much memory, and the processor isn't very fast. But nonetheless, it is there. Open Hardware Core 5 is working on their chassis for a SoC. They took an IMX processor board, which previously ran ARM, and they replaced the ARM processor with a RISC-V. As a test project only, I don't know what will happen with it. They're probably going to release a few limited boards, probably by the end of the year, is what I've kind of heard. But the one that probably has the most excitement, I mentioned this the last time, at the end of December last year, is PolarFire, and that's expected in the third quarter of this year. So that one is actually a SoC that you can stack. So I keep getting more and more details for this, but it has a 10 gig Ethernet interface, up to a 10 gig Ethernet interface, and 4 cores, but you can stack up to 6 of them to create a larger machine if you wish. Sounds to me like that might be IoT-based focus, maybe even switch-based focus. but I'm not sure. We'll wait and see how general purpose that is. And so, since we're not getting a lot of chips yet, the FPGA camp has been busy kind of creating some hardware for us to use. And there's a project called Project Trellis, which is bringing together the code base that you need to load onto the FPGAs in order to create a RISC-V environment, an execution environment. And Radona, I think that's the way you pronounce it, they have a XLX33S, which is, I think they're Croatia-based, and they're working on one. I don't know where that is. I haven't looked, to be honest. But there's also the Orange Crab, which is another Adafruit-sized board, very small. And then I noticed, looking today, when I was looking at the list of RISC-V Foundation members, I saw a Raspberry Pi Foundation on there, and I find that highly intriguing, that they have joined the foundation. So what will come of that? I don't know, but it's interesting to see them there, and I'm glad to see them there. There's no hardware. There's also these things called no hardware-based emulators, and one of them is from Renode. Renode is a piece of software that you can download, and you can, from the list, you can choose which board you want to emulate, like the Sci-Fi boards. You can pick Unleashed or one of the other ones. There's several boards that they have, and then you can run the environment on your machine as if you were actually using those in emulator, that particular board. Now, the problem I've always had with emulators is generally they run at the speed of the host computer. So I'm not sure. I'm going to have to go play with Renode. Don't know a whole lot about it. Just saw it in passing recently, and I want to go see more about it and check it out and see if it adjusts the timings to match the actual hardware that you're trying to run as. Because timing-based problems usually happen because the clock is off from the hardware. If you go to try to install something on the real hardware and your clocks are slower, you can run into trouble. So anyway, yeah. So that's all I had for today, and just a few updates of what's going on. And I hope you enjoyed this, and hope to see you again real soon. And as always, please like and subscribe, and talk to you next time. Bye for now.